find the binding energy of Te 52126 by using semi-empirical formula. You know, the simulation of liquid trap model, or by using mass defect. You know, you can find the binding energy by binding energy equals to Z M P plus N M N C square minus M N C square. It's more accurate as value. This value here, it will be more accurate. Or you can find the binding energy by using the semi-empirical formula. You know, the volume term, surface, symmetric, and so on. And a pairing term. Anyway, I give you the mass of one proton in atomic mass unit, the mass of one neutron in atomic mass unit, and the mass of the nucleus of Te. Okay? And here we have the equivalence between 1U is equivalent to 931 MeV. It's not equal, it's equivalent. Okay? I talked about this point in the last video. If I give you the value, the unit of the binding energy in atomic mass unit, in order to convert this unit to MeV, you have to multiply by 931.5 MeV. Okay? For example, if I give you the binding energy equals to 5 atomic mass unit, you have to write this value equals to 5 times 931.5 MeV. You have to convert the unit to MeV. Okay? Okay, let me solve this problem. You know, we can write here the semi-empirical formula. You have to know this equation very well, because I don't give you this formula. You have to know it and you write it directly. You know, I give you the value of AV. We have A equals to 1 to 6. I give you the value of A surface and so on. We have all the values. Here, be careful. I write plus, here we have plus delta Zn, the pairing term. Why I put it plus AP times A power minus half? Because we have even number of protons and neutrons. Okay? For this reason, if we have a even, you have to put plus. If we have odd, equal to 0. If we have odd, even, you put minus. Okay, because it's very important. As we have even, Z and N number, in this case, you have to put positive. You substitute the values. Here, you get finally this value of binding energy. The second part, I want to calculate the binding energy by using the general formula of binding energy, ZMP plus NMN minus MNTE C square. we can substitute the value of Z and P, and be careful here. C square equals to 931.5 MeV divided by U, because I use the atomic mass unit here. So you have to put 931.5. Anyway, you can write the answer here. And if you compare this one with this one, the two answers, you can see the binding energy calculated by the normal equation, by this one, is greater than the binding energy calculated by the semi-empirical formula. Why? In general, this value is more accurate, and the value calculated by the semi-empirical formula has some uncertainty, okay? Because the values of AV, of AC, A coulomb, A symmetric, A volume, A pairing are not accurate, are not, we have some approximation, okay? For this reason, we have some difference between these two values.